In this lesson, we are looking at symmetry. Our essential question is, how do you determine whether a figure has line symmetry or rotational symmetry? Our standards are GCO A3, given a rectangle, parallelogram, trapezoid, or regular polygon, describe the rotations and reflections that carry it onto itself. Symmetry. A figure has symmetry if a rigid motion exists that maps the figure onto itself. Line of symmetry. A line of symmetry is a line that a figure in the plane has if the figure can be mapped onto itself by a reflection in the line. So if you can look at this picture, you'll see that in this picture over here, we have no line of symmetry if we cut the rectangle diagonally, because you can see that when we cut the rectangle diagonally, it does not fold onto itself, so there's no line of symmetry diagonally. However, if we cut the rectangle in half vertically, we can fold the rectangle over the line of symmetry evenly and onto itself, and so we have at least one line of symmetry over here. Rotational symmetry. A figure in the plane has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 or less. What that means is whenever I turn the image 180 degrees, either clockwise or counterclockwise, I still get the same image, so it doesn't look like anything's changed. Finding lines of symmetry. How many lines of symmetry does a figure have? Remember, when we're looking for lines of symmetry, we're looking to see if we can fold the image over the line of symmetry evenly so that all points line up. And some images may have one, some images may have none, some images may have more. So you just have to play around with it. In our first one, we have an oval, and if you look at it, we can fold it in two different ways evenly over the line of symmetry. So this oval has 2 lines of symmetry. Pentagon has 5 lines of symmetry, so there's 5 ways that we could cut the pentagon in half and fold it over the line of symmetry so that all of its points match up. And finally, the octagon has 8 lines of symmetry, meaning you can cut the octagon in half 8 different ways and fold it over the line of symmetry so that all the points line up. Alright, checkpoint problems 5, 6, and 7 are yours. Determine the number of lines of symmetry that the figure has. Here is figure 5, 6, and 7. How many lines of symmetry does each figure have? Yeah, identifying rotational symmetry. Does the figure have rotational symmetry? If so, describe the rotations that map the figure onto itself. So our first example, we're looking at an isosceles triangle. No matter how many degrees I turn the isosceles triangle, either counterclockwise or clockwise, unless I turn it 360 degrees, I cannot make this triangle look like it's original. So I cannot map it onto itself. So the isosceles triangle does not have rotational symmetry. B, I have a rhombus. The rhombus, if I turn it 180 degrees, either clockwise or counterclockwise, it would look the same. So yes, this rhombus has rotational symmetry. It can be mapped onto itself by a clockwise or counterclockwise rotation of 180 degrees about its center. Finally, a regular hexagon. I can turn this hexagon about 60 degrees, either counterclockwise or clockwise, and it will look like it hasn't turned at all. So yes, this hexagon does have rotational symmetry. It can be mapped onto itself by a clockwise or counterclockwise rotation of 60 degrees, 120 degrees, or 180 degrees about its center. Alright, checkpoint problems 3, 4, and 5 are yours. Does the figure have rotational symmetry? If so, describe the rotations that map the figure onto itself. Here's checkpoint problem number 3, checkpoint problem number 4, and checkpoint problem number 5. Alright, that's it from me. I'll see you all soon.